You guys are live.
We'll go first and do it. Okay. So the question was, what is the volume released by a gas in one Alka-Seltzer? So our table shows the number of trials, the number of tablets, and the gas volume in milliliters. As you can see, all units are there. We did 5 trials because we had extra time, and for each gas volume in milliliters, we got roughly 60, around 60. So our claim is that the volume of one Alka-Seltzer is 60 milliliters.
Okay.
It's a guess.
Yeah.
Who's got 2? The volume for 2.
The volume of the gas.
Who's got 2 Alka-Seltzer?
Oh, we do. So we did 4 trials of the 2 tablets of the gas of the Alka-Seltzer, and we didn't make a claim because I don't think that we have enough data to make a claim because it's like kind of like every other that type of thing. So I think we need more data to like confirm which one it is.
Okay. Who's got 3?
So our question was, what is the volume of the gas released by 3 Alka-Seltzer tablets? And our change for the first trial was 265 milliliters. The second was 385 milliliters, and the third one was 295 milliliters. And we said that the average volume of the gas was about 315 milliliters.
Okay. You also had 3?
Yes.
Okay, good.
So we had a lot of errors throughout our trials because our changes range from 100 milliliters to 400 milliliters. And this is because not all the Alka-Seltzer went into the cylinder, or the change was below the 500 milliliter line, so we had to guess, or the water for Alka-Seltzer leaked out into the bin. And so our claim that we can take from this data set is the change in volume of 3 tablets of Alka-Seltzer is always above 100 milliliters.
Okay.
We also had 3. Our claim, or at our table, we averaged around 441 milliliters released, milliliters of gas for the volume, and then we definitely, I think we had some error. There was a couple times where we tried to, we couldn't get the Alka-Seltzer under the graduated cylinder as quickly as we would like.
And then our claim is the volume of the gas released by 3 Alka-Seltzer tablets is about 441 milliliters. And we also probably messed up because we had to guess parts of the graduated cylinder that weren't already measured out. So,
yeah, like if the graduated cylinder went it stopped, the markings stopped at 500 milliliters, and then they went below that. There's some space at the top. If you see one, the markings don't go all the way to the top, so you have to kind of estimate where the markings would be in that area.
Okay. So let's do. Oh, I'm sorry. You used 4.
Yeah, we have 4. So we took. So we had 3 trials, and our first 2, the gas volume was pretty consistent. We had 525 and 530, but our third one was an outlier, and we had 275. So it was 2 out of 3 were good. And then our question was, what is the volume of the gas released from 4 Alka-Seltzer tablets? And in the end, we didn't really have that much data for our claim, so we tried to say when it was the more tablets that are put into the beaker, the more volume of the gas, the more volume the gas has. So that was our kind of not a great claim, but that was our data. Yeah, and sometimes we put 4 underneath and we would shut the beaker, but it would break off half of a tablet, so it's kind of hard to be perfect.
Perfectionism. hard. Okay, let's do mass.
We're number 1. Should we go through?
Sure.
So yeah, this is our data for the mass of gas released by 1 Alka-Seltzer tablet.
We like measured the before and after and the difference, and then we averaged it. So and that was 0.22 grams. So our claim was that the mass of gas released by 1 Alka-Seltzer tablet is 0.22 grams.
Wait, so the before, is that the water or the weight?
That's the weight of the
the
water in the Alka-Seltzer, but the Alka-Seltzer is not in the water.
And
So your claim is
that the mass of gas released by 1 Alka-Seltzer tablet is 0.22 grams.
okay. 2.
Wait, for the difference average, where are you getting that percent
Wait,
from?
what?
Yeah, like what is that 22%?
That's just what we converted from the oh,
It's not important.
Okay.
there's just a note.
Okay. 2 tablets.
Okay, that's us. So our question was measured before and after, found the change, and then we averaged out all of our trials, and we did 3 trials, and we said that the average density, the average mass of the gas released is about 0.47 grams.
Wait, for yours, so when you were measuring it, you also did it before and after of the water with the mass of the tablet.
Is that a gram time? 0.34?
Yeah. Get some hard numbers.
Okay.
For your graph, is it just a histogram, or are you using? Oh, you use both data points.
Yeah.
So just, so yeah.
Okay. Who's got 3?
Okay. We had 3 Alka-Seltzer tablets, so our question was, what is the mass of the gas of 3 Alka-Seltzer tablets? And we found our average to be 1.71 grams. All of our data points fell into that range of the average, except for our first one, which was 1.57 grams. And after we did the first one, we actually changed our strategy a little bit.
And the average of only our final 3 was 1.75, which was a lot more in the line of our data. It was only about 0.02 away from each of these. So number 1 for us was definitely an outlier.
Is the measurement of the grams? Yes.
So you changed your strategy, like what's that mean exactly?
We used less water in the buckets of the beaker.
When you say mass of the gas, how are you measuring the gas?
Well, it's the change.
Right, but how are you, when you measure the gas? Oh wait, never mind, that's a stupid question.
Wait, so when you were taking away some of the water, did you keep the constant water?
Yeah, well,
Because
yeah.
in your graph it says 240 and all the others are below.
Over here?
No, for the before.
Yeah, so it's, if you just kept it around later.
Yeah.
How did lowering the water help with the final results?
It made it more into the same range.
Yeah,
Because the first one was 1.57.
Do you know why?
It let less water escape probably.
Yeah,
it
less
was
water.
just-
Because it was the line was lower, so then there was more space in the beaker above, so less water could escape out of the top.
Wait, so in your graph, you have 3 pictures of bar graphs, and one is higher, a lot higher than the other, since your graph is really condensed. So, does that mean that we were using the 1.57 in the other one, or?
The graph is very
Yes,
small.
we ran out of time, so we just had to put it together.
So the question now is, do we believe our data? I mean, that's what we need to make. That's what we need to make sure before we leave this room. Do we believe our collective data?
Either we
One more. Two more. Okay.
So we also did 3 tablets. And so originally we were going to do a different strategy with a balloon. It didn't end up going well, so we just kind of scratched that and then did the regular way. And so we found that the average mass by 3 Alka-Seltzer tablets is 8.507 grams.
And so we made a graph of the difference between the Alka-Seltzer and the gas mass. And so we came up with the medium, and it was 1.5705 grams of a mass. And our tests show that the difference was near the same point.
For your data, how are you getting the mass of the gas?
We weighed the water, then we weighed the Alka-Seltzer, and then we added them together. Then we weighed the water afterward, and then we subtracted it.
I think it's just kind of confusing to look at because you only show the initial, so it's hard to figure out where that number is coming from.
It'd be more helpful if you had like the before, so like with where you added the Alka-Seltzer and the water, and then the after where the Alka-Seltzer is dissolved in the water. Yeah, that would make a little bit more sense just to look at.
What was the problem with like when you tried to do the balloon method to find the mass? Like what went wrong?
Oh, the water got in.
Yeah, the water was in the balloon, and then we tried putting tin foil so that no water got in the balloon, but then the water like kind of exploded. So we just
Take a balloon pop.
Well, so I see like that you said the average mass of the gas released from the Alka-Seltzer by 3 Alka-Seltzer tablets is around 8.507 grams. How did you come across that number? Because it seems like kind of large compared to the other
That was my question too.
like that one where it's like 1.7 for also for the Alka-Seltzer tablets.
It's just your guys' data is like very different, so I was wondering if you guys had any comments on sort of like, do you guys think one is more right than the other, or do you think you know what might have caused this sort of jump?
No, it might have been our data or the other group's data. We won't be sure because we didn't take enough tests and it's uncertain.
You guys said there was another board? Yep.
okay, so we did 4. So basically what we did was, obviously we did the same thing as the other groups, just with 4, and most of our change in mass answers, I guess, came out to around 2. And so if you look at our graph, it's kind of all around the same points. We also calculated our percentage error, because we know if it's below 5%, our answers should be, we can like conclude them as valid, which was below 5%. It was 3.5%, which means that our answers are valid. So we concluded that our average of 2.01 grams was correct.
Okay. What was your process to get a 3.5% of like no errors or change?
So we took all our data points and found the average, and then the largest difference from the average to any one of the numbers, we took that, multiplied it by 100 to get the percent, which is 3 points.
So when you say it's like accurate, you mean in terms of relation to the rest of your data, right? Because you can't really know how it is compared to like the rest of the group's data unless you took the whole average and then compared.
Yeah, we were just saying that it's within 3.5, so they're all, there's no big outliers, and so they're all most likely correct, because they're like, we got the same number within 5% every time we repeated the experiment.
I think they were just talking accurate as in just accurate
More
within
consistently.
Yeah, just within their own data. Also, I just had another question about the balloon, or maybe just generally speaking, like, is our data valid? I think it is valid, but then there are a couple like things that make the method that we retrieve them different, such as the balloon method, and a couple people that may have like measured things incorrectly compared to the rest of the group. So I guess it is valid besides the outliers.
Yeah, I think we could all be a lot more precise with our measurements and the procedure, keeping like a consistent procedure.
I think those outliers are kind of, I think we have to figure it out if we're going to have a class communal data table, what data we're going to use. Are we going to use some of these outliers like the balloon and some of the other people who use different measurements, or are we going to take more of the way most people took with the standard operation?
I thought it was interesting, Emily and I thought it was interesting that for our gas volume in milliliters, we got roughly like 60, and on Alice and Maddie and Joe's board, they got 120, and we got one tablet and they got two tablets, so it kind of makes sense that that our tablets have this volume.
Yeah, because we didn't do the experiments together, so the odds that we made the exact same mistakes to get like the same sort of proportions are lower.
Yeah, I think we also need to make sure that our data points are not only like accurate, that they're not only accurate, but they're also precise. Like it's also important that our data is like close to each other. So like if there's data that's like that's really far away from each other, each data point is like all really far away from each other, then that's not very precise. And so.
Okay, I was going to say, how do you think we can be more precise in the way we conduct our experiments?
I think that we could find a way as a group, all of us collectively trying to find another experiment that would be more useful and more exact than the ones that we've tested so far. So
that, or we just like hone down on this one experiment that we already have.
And we make sure that we're all on the like same page, that no one like added a step or skipped steps, that we're all following the exact same procedure, because that'll raise the accuracy of our data.
I agree with Sam. I think we don't have to find a new method. I think we can just work on improving the method that we already have.
Yeah, I agree.
Also make sure the water doesn't spill. Happened a few times.
That seems to be a recurring issue, is water spilling.
Yeah.
Or if we are going to come up with a new procedure, make sure that everyone agrees on it and everyone does it, so that way it's accurate.